We continue our discussion on this result that we got. So we need to go and find here some numbers that are close to 90, okay, 900. So I'm gonna get here this one. So I'm gonna put here 155. Okay, we get now 924, and that's the thing that I told you in a practical way. And let's make it 153. Something very weird is happening here between 153 and 155. Many guests are over there. So let's check it also. And so now we have the okay, now when we check the area here, we notice that we have this part that covers that 90% area. So I'm gonna make it green. Okay, and now here we can put that probability that we are looking for, that is 90%. So it would be the number of people who are, if we get prepared for 100 guests, 97 out of 1000 will be smaller than 100. So the service level would be this low number that is not acceptable. I'm gonna also do this percentage. So we need some numbers that are, you see, it says the minimum, according to the activity, it says the minimum number that covers at least 90%. And now you can see here. So you can see here, we need to be prepared for 155 guests. See how much interestingly we got the answer for that challenge. And now I'm gonna run the model more times, and you see 92, 93, 94. So it means that according to this system we need to be prepared for 155, because according to that simulation that you see in front of you, 93% of the situation out of 1000, the number of guests are equal or less than 155. What if we get prepared for 154? Again, according to the simulations that we have, 85% of the cases are smaller than that. So the answer to this question would be 155. You also, when you run it on your system, you should receive the same answers. These examples that I'm doing for you, it's the first time that I'm doing it. So I hope I don't have any typo or anything. So if I don't have any typo, you should also get similar answer. Oh, for example, see here, even 91%. So it shows that 155 is very reliable. And you may ask why we shouldn't go for 160, because when we can achieve our required or preferred level of service with 155, why you should go with 160. So I'm running it again, and it seems that 155 is the answer. And again, I'm saying that if I don't have any typo, and you also don't have any typo, if I assume that I don't have any typo, you should receive the same answer. Just in case you don't get the same answer, reach out to me. we figure it out together, because there is a chance that I have made the mistake, but I tried my best. Okay, now we are good with this activity. As the last activity that we want to do is doing the simulation separately for each invitation. In the previous simulation that we had, as you noticed, we consider the simulation of all of one RSVP together, 25. All two RSVP all together, the 61, and the ones that without answer, with no response, all together. But here we are going to do it independently, and we are going to simulate each simulation. We are going to simulate each invitation. Here is the previous simulation, and as you can see, my friends, for 25 guest invitations that we received as one RSVP, for 25 of them, we considered only one column. As you can see here, we have 25 times. The same thing with for the 62 RSVP invitation, and also for no response. But now we are going to continue this. Again, I'm telling you, this answer is reliable, but just since we want to check the results for the other one, we are gonna do that. So what we are gonna do is this, and of course I'm gonna pause the video so you are gonna do it, and but I'm gonna tell you about the process. See, here we have one RSVP, and they are from the category of one RSVP that we have 25. But instead of multiply them by 25, we are gonna create for each of them an independent column, and after that we sum up the answers. So what happens here? I'm gonna first create the empty space for what we need. So okay, now you see what we have. Now all of these guests that have been simulated here have RSVP'd as one, but instead of multiply them by 25, here I have created 25 simulation for each of them. As I told you, it is not necessary, just we are curious to see the results and show you why the previous one, although make everything much simpler, still reliable. And you pay attention to the formula that you see here. There is no multiplication by 25. Now this simulation is very exact because we have simulated each guest, as you can see. You should continue the same thing with the 2 RSVP, that there are 60 guests over there. In the next step, we got the simulation for the 60 invitations that have been RSVP'd with a companion. And as you can see here, and there is a simulation for each individual one in that. And after that, we go for no response one, and after that, we sum up all the answers to see what would be the difference between two structures. Again, I'm telling you this way that now I'm not recommending it, but I just want to justify why the simplification we had with the previous structure is working. And if I show you the individual formula that we have used, you see there is no multiplication by 60. And here you can see the simulation for no response one, and the formula, as you can see, there is no multiplication by 10 for all of them. and we have done it for 10 invitations in this category. Okay, now we are done with this simulation because we simulated individually each of the invitations, a lot of work. And when we go according to the activity and it asks us for the average, you see the average is 134, very close to the previous one. So you see, when we want to calculate the average, the answer with the previous one, that we just multiply each invitation by the number of that category, is completely reliable. But the difference in the answer here, you can see regarding the probability, since we are using individual invitations, so the results would have less deviation, less fluctuation. So as you can see, we can get that desired service level of 90% when we are prepared for 141 guests. If I run it another time, okay, so again, you see even 140 can be the answer. And remember, we are doing it on a basis of practical measures, and to get better results we need to run for more we need to run more simulations. For example, instead of 1000 we should go for 5000. And it was not the part of the answer for activity, for the last activity. I'm just doing it since there is still time, and I just want to show you. So here there are different, because in the previous one, as far as I remember, for the previous one it was 155, but according to this model it says that you need to get prepared for yeah, you need to get prepared for 140 or 141. And since we here have done individual simulation, it is completely reliable. So it says that on a regular situation, we don't have any case in which, for example, we have 150 guests over there, and it is more reliable when you want to come to this decision. But about the average, you can see they both work similarly. And so here we come up with the answer that the number of guests that we need to be prepared for is 140, because 90% of the cases the number of guests would be smaller than 140. You may ask, what is the reason for that difference? Remember, in the previous one, we made it simpler for us just because we wanted to make the simulation model, and we assume that the people who are coming alone, we categorize them in one category, and we assume that all of them are gonna act the same. And all of them, for example, the people who are um, RSVP'd with the companion, all of them are coming to the wedding according to similar model. That is not a good assumption if you want to go for more serious assumption. But about the average, absolutely it works. But about the other thing, because it is not acceptable that you say all of the people who are SVP'd according with the companion are gonna act the same. Each individual in the invitation is individual decision. So we need to consider them separately. So the results now are reliable, and the number of guests we need to be prepared for would be 140 in that situation. With the probability of 90%, we are prepared for our guests or even more numbers.